All right, here we go. You're used to this by now. This is the test corrections video for the first midterm. Before we start with the first question, make sure that you have your test corrections packet out. It looks like this, and your job is to copy the original question, including the words, because you need to learn the instructions here as much as you need to learn the math. Then work out the example given in the video. Then write and solve an identical question. Solve it here on this piece of paper, and when I say identical, I mean for you to copy the same instructions and language in the original. And once you've created that identical question, you have the work here. I recommend making the question first so that you can see what the answer choices should be. But then the actual question goes on this piece of paper, including answer choices. It needs to be a multiple choice practice problem that you can share with your peers. Great, let's get started with question 1. Question number 1 was basically just a very simple derivative problem. Really, all you needed to do was take the derivative, and I did it using the power rule, which meant multiplying the exponent 4 times the coefficient that was already there, and then subtracting 1 from the exponent, which turned it into a 3. I followed the same step on the second term, multiplying the exponent in front and then subtracting 1 to get an invisible exponent of 1. From there we just simplify and then of course plug in the x value. The only important thing to remember is you have to take the derivative first before you plug in. You can't plug in first. And here's the question that you should do. Remember that you can't use the calculator. And here's the answer. Just like in the test question, we take the derivative first, and then we just plug in the number. Pause for longer if you need to look at the answer, otherwise we'll move on to the next question. Question number 2 is really just a matter of understanding the rule about degree. When you have the limit as x approaches infinity, and this only works if x is approaching infinity, but if that's what you're looking at, then all you need to do is look at the degree on the top and the bottom. If the degree on the top and the bottom are the same, then the answer to the limit is the same thing as the coefficients of the top and the bottom. So in this case, it would be 1 over 4, which is why the answer was C. If the degree on the top is higher, then infinity would become your answer. Well, positive or negative infinity. Think about it as plugging in really large numbers. Here, I have large numbers on the top and the bottom, and they're about the same amount large. So they end up canceling each other out, and I end up with a number as my answer. If the degree is higher on the top, then I have a really large number on top. If that really large number is positive, then my answer is positive infinity. If my really large number on the top has a negative coefficient on that highest term, then the answer would be negative infinity. If the highest degree term is on the bottom, then we imagine having a really large number on the bottom of a fraction, which is kind of like dividing by a really large number. And when you divide anything by a really large number, you end up with answers approaching 0. Here's one for you. Right, so in this case, the correct answer was A, which is infinity. And that's because the highest degree in this expression is x to the 5th, which is on top. And furthermore, it has a positive coefficient. So since it's on top, our answer is either positive or negative infinity. Since the coefficient is positive, the answer is positive infinity. If you think about it in terms of numbers, x is getting very large. The output of the function is also going to get large because that term on top is very large. And that basically means it's approaching positive infinity. In question number 3, we start with some terminology that you need to understand. Don't skip the words. Use the words, they'll help you. F and G are differentiable functions. Okay, so we have 2 functions. Such that by something, something, something. So they're telling us things that are true. They're telling us that f of 2 is 3. In other words, when I plug in 2, I get a y value of 3. Then they tell me that the derivative of f prime, the derivative of f at 2 is 4. And if I plug 2 into g, I get a y value of 1/2, whereas the derivative of g at x equals 2 is negative 1. And then they ask me for the derivative of the product at 2. This is just a simple product rule problem. To start with, I take the derivative of the product, then last step is to plug in 2. So fg prime really means the derivative of f of x times g of x. In order to take the derivative of a product, you can't just take the derivative of the first and multiply it times the derivative of the second. You have to use product rule. This is just product rule. Then to plug 2 in, and this is just to get my answer, I basically just plug 2 into each of these 4 pieces and multiply out the answers. From here, you just have to be careful with the order. F of 2 is 3, so I plug in 3 where it says f of 2. G prime of 2 is negative 1, so I plugged in negative 1 where g prime of 2 is, so on and so forth. Last step, be careful with your negatives. Negative 3 plus 2 is negative 1, which is why the answer was E. Here's one for you. So this question was just a quotient rule. And you can see that I applied the quotient rule first. This is a subtraction sign, ignore the little extra parentheses. And then after setting up the quotient rule, only then did I plug in 2. Substitute the numbers. The simplifying may have tripped you up, so just notice 1/2 times 4 is 2. Negative 3 times negative 1 is positive 3. And then I change flip here at the end. 5 divided by 1/4 is the same thing as 5 times 4, which is why the answer was 20. Okay, question number 4 proved to be quite the stumbling block, so let's talk through this. First things first, you recognize this function, and the first thing you should see is the glaring multiplication sign. And it's right here, in case you missed it. This is a product rule problem. Now, it's not just a product rule, because the things that we are multiplying, one of them involves an exponent. And so there's going to be a chain rule. But the overall structure of this is that there are 2 things being multiplied times each other, and we're trying to take the derivative of that. So we use the product rule, and I really like to set it up first, just using these little reminders, u dv plus v du. And then I fill in everything that's easy. U is easy, it's the first part. V is easy, it's the second part, including the 3. And du is also really easy because the derivative of this is just a simple power rule. Now, this is hard, and so in order to just keep all my terms together at the first step, I like to write d dx just as a reminder that I need to take the derivative of this. And now when I get down to thinking about it, I see that taking the derivative of this is going to involve a chain rule. The outside function is something cubed, and the inside function is x squared plus 2. So when I take that chain rule, the derivative of the outside function is 3 times something squared, and then I plug in the inside function. And onto the back, I tack the derivative of the inside function, which is 2x. So this whole term right here is the derivative of v. From there, I bring everything else down. I just distributed the 1. And if you got this far, then great, you're fabulous with the calculus. But what tripped you up was the algebra, because now we have to simplify, and that's a little bit tedious, but not hard to understand. First of all, look at this expression and figure out how many terms there are. Right, so you should have come up with the fact that there are really just 2 terms. All of this is being multiplied. There's some binomials, sure, but it's all being multiplied, plus this right here. So make sure you keep those 2 terms intact all the way through the problem. And accidentally adding in addition signs is a really common way that people have gotten things wrong. In order to simplify this, since I'm multiplying all these things, I'm just going to start by gathering the easy pieces first. 2x times 3 is 6x, and I brought everything else down. Next, what I see here is kind of tricky, but I'm seeing that this x squared plus 2 seems to be kind of a common term in both of them. And actually, in order to better see that, I went ahead to distribute the 6x into both of these terms, hence the 6x squared minus 6x. But looking at this, it seems like there might be a GCF here. Now, these aren't exactly the same because the exponents are different. So in order to better see the GCF, I'm going to take this last expression, and I'm going to rewrite it as x squared plus 2 times x squared plus 2 squared. Think about it. This is something plus itself squared. Together when you multiply them, they're the same thing as that thing to the third power. I'm allowed to do this. If I multiply these together, that's the same thing. Now the reason I wanted to do this is now I really do have a GCF. The exact same thing is being multiplied times the first term and the second term. So that thing I can pull out front. And what's left is 6x squared minus 6x plus x squared plus 2. And this expression right here is the same thing as this expression. You just do your little combining like terms, and that's where the final answer came from. Great, so here's a similar question for you. Okay, so you got the answer, it's E, and maybe you guessed that because of my whiteout situation, or maybe you got it right, but let's make sure that you understand the simplifying process again. The setup is just the product rule, which is not hard. The chain rule comes in this time when you're calculating du, and that's because your u function has that exponent. So there's an outside function, which is something to the fourth power. The derivative of that is 4 times something cubed. Then you multiply it times the derivative of the inside function, which is x cubed minus 3. Now, simplifying, let's look at each of the steps. Remember how we always look at how many terms there are? Technically, I've got 2 terms. I've got all of this plus all of this. So I'm going to simplify each term separately, and then at the last step, take out a GCF if I can. What I did here was first I multiplied the 3x squared times the 4 just within the du. Maybe you had already done that. That's where the 12x squared came from. Then I distributed the 12x squared because this is all still my second term. It all belongs together. And that's where 60 and 24 came from. And then I'm starting to recognize this similar term at the back of both the front and the second term. Now they're not exactly the same because there's this 4 on the first one. So it's like something to the fourth and something cubed. But the somethings are the same, which means there is a GCF to be taken out. And the GCF is actually x cubed minus 3 cubed. Now, in order to take that GCF out, I've got an extra one here, if you imagine it. So that extra one I'm going to separate out and multiply times 5. And so 5 times x cubed is 5x cubed, and 5 times negative 3 is negative 15. So it's like I took away the extra and multiplied it times the 5, and it ended up right here. And then there were 3 of these terms left being multiplied times each other, and that's this term here. Now the back didn't change at all at this step, but now I'm ready to go with my GCF because this term, x cubed minus 3 cubed, is the same on the front and the same in the back. So I pull it all the way out front, and in parentheses, I keep essentially the coefficient of the first plus the coefficient of the second. If you imagine distributing this in to the front and to the back, we would end up with this expression. It's the same structure as normal old distribution like this. It's just more complicated pieces. From here, I just combine like terms. 5x cubed and 60x cubed make 65, and I moved the cube term to the back. It's not right or wrong. The point is that when you simplify, there's a lot of ways your work can end up. All right, question number 5 was short and sweet. 83% of you got it right. This was just a basic chain rule question. I really am into this chain rule strategy where I use parentheses with the outside function. So if you haven't yet converted to doing this, do it now. It's really best. The outside function here is ln of something, and leave it as with the something. Don't use x's. So when you think about the derivative of ln of something, it's clearly 1 over the something, no x's. Now inside of this parentheses is the function cosine of 3x, which is actually another chain rule. And the derivative of cosine of 3x is negative sine of 3x times 3, because 3 is the derivative of this little inside. And then we put it all together, start with the derivative of the outside, plug in the inside, tack on the back. Don't use this first one. And the rest is history. There's a little bit of simplifying here. Notice that sine of 3x over cosine of 3x is the same thing as tangent. And for you? Okay, right, so this was maybe a little bit too similar, but it's just another chain rule with ln on the outside. the derivative of sine is cosine, and you just plug everything back in.